All right, so this is going to be a video about solving quadratic equations, and namely we're going to be focused on solving them by factoring. So it says here, solve by factoring, solve by using square roots, and solve by using the quadratic formula. First, a quick review of what a quadratic equation is. It says it basically right here. So basically a quadratic equation has a form that can be broken down to look like this right here. Okay, ax squared plus bx plus c equals 0. And it is important to note that a cannot be equal to 0, because if it was, then it would just be a linear function instead of a quadratic function or equation. This is an example of a polynomial equation, it says right here. In fact, it's a second degree polynomial equation because the highest power of that polynomial is squared, so that's why it's second degree. It says there are 3 common approaches for solving the quadratic equations. This is what we're going to be talking about today. This is what we're going to be talking about in this video. Factoring, using square roots, basically just completing the square, and then using the quadratic formula. Using factoring to solve quadratic equations, basically it's called a zero product property. Essentially, if you are multiplying 2 numbers together and they're equal to 0, that means that either a is 0 or b is 0 if a and b are those 2 numbers. Okay, which kind of makes sense. If you had a times b equals 0, at least one of them has to be 0. Okay, I mean, I guess both of them could be 0 as well, but at least one of them has to be 0. And essentially that's what we're going to do when we factor, is we're going to set one of them equal to 0, one of the factors, and then we're going to set the other factor equal to 0. It is important to understand that a factor just means the numbers that you're multiplying. So that's what I mean by when I say factor. All right, so let's solve some of these example problems right here, and hopefully this starts making more sense. All right, number 1, it says solve for x. Essentially what we're going to do here is it's already set equal to 0. So what we're going to do is use zero product property. I'm going to set 2x plus 1 equals 0, and then x minus 5 equal to 0. Okay, I mean, this is just linear equations, basically similar to previous stuff that we learned about. Here, x is going to be equal to -1/2, and here, x is going to be equal to 5. It is important to note that you can check your work on these by just plugging in these x values into the original equation and seeing if it is in fact equal to 0. So you can kind of do that real quick and see that it is in fact the answer. All right, the next one is not actually quadratic, but you can still use factoring to solve it. Essentially what we're going to do is every single one of these factors I'm going to set equal to 0, and then you can solve this equation right here, since it's equal to 0 over here. So we're going to set 3x equal to 0, x minus 1 equal to 0, x plus 3 equal to 0, and x minus 9 equal to 0. So then you should have x equals 0 as one of the answers, x equals 1, x equals -3, and x equals 9. Highlight all these real quick. And those are the answers for that one. Okay, this one right here involves a little bit more work because, as you can see, it's not actually in factored form already. 1 and 2, the examples we just did, were already in factored form. This one we have to put into factored form, and I'm going to show you a method of doing this right now. There's multiple ways of doing it. I just think this is the best way. Essentially what we're going to do is we're going to multiply a times c. In this case, our a is 1. It's going to be 1 times our c, which is -3. So it's going to be 1 times -3 is equal to -3. And then from there, I'm going to take what our b is. In this case, our b is -2. That's this right here, is your b term. Remember, this was part of the definition of what a quadratic equation is. Basically says it right up here, highlighted in red, the ax squared plus bx plus c. So the a is whatever's with the x squared, the b is whatever's with the x, and the c is whatever number is just by itself as a constant. Okay, so that's how I got this a times c and this b. And then the next step, what you're going to do, is you need to figure out 2 numbers that add to b and multiply to ac. Okay, so you have to think they add to b, so they add to -2, and they multiply to -3. So the numbers are going to be -3 plus 1. And essentially what we're going to do with that -3 and plus 1 is we're going to split the b term. So that's the next step on this, is splitting the b term. So we're going to have -3x plus 1x minus 3 is equal to 0. Okay, so I'm color coding every step. Step 1 is find AC. Step 2 is split b into 2 numbers that add to b and multiply to AC. So if you notice, -3 times 1 is -3. -3 plus 1 is -2. So those two numbers check out. And then what I'm going to do next is split that b term. So if you notice right here, -3 plus -3x plus 1x is equal to that -2x. So you can kind of see this color coding. The original equation and that green equation are actually the exact same, just written a little bit differently. Next step is we're going to factor by grouping. So I'm going to group the first two and group the second two here and factor each of those. And you can factor an x out of here and you get x minus 3. You can factor a 1 out of here and you get x minus 3. It is really important to note that you should have matching factors for these. Sometimes you have to mess with the negative sign to make sure that these factors match. And then the last step is to factor one last time, and we're going to factor out an x minus 3. And we're going to write in an x plus 1 once we do that factoring, and then set this equal to 0. Now it's in factored form. This purple right here is in factored form, similar to the first two example problems we have. So now we can just set each factor equal to 0, and you should have 3 as one of the answers and -1 as one of the answers. And that's the answer for that one. Okay, onward we go. Okay, this one it says solve by factoring. Again, we're going to have to use that AC method. So first thing we're going to do is figure out what AC is. AC is equal to -2. Okay, our B is equal to 1. There's just an invisible 1 right there. So two numbers that multiply to -2 and add to 1. So those two numbers aren't too hard to find. It should just be 2 and -1. So 2 plus -1 is 1. 2 times -1 is -2. That's perfect. What we can do next is split that middle term. So we're going to have v squared plus 2v minus 1v, minus 2 is equal to 0. We're going to factor by grouping, so I'm going to group the first two. Here I'm going to actually group that negative in there rather than doing the minus. It's just a little bit easier to work with. Okay, I'm going to factor out a v on this first one, v plus 2. I'm going to factor out negative here because if I do that, you'll have a v plus 2. If you remember, I told you these factors have to match. This has to match with this. So that's equal to 0. I'm going to factor out a v plus 2. With the v minus 1, set that equal to 0. The last step is to solve each of those equations equal to 0. So you have -2 and you have 1, and that's the two answers for that one. All right, this next one, I'm going to rewrite it because it has to be in standard form, and right now it's not. So I'm going to add 13u to both sides. In standard form, it should be equal to 0, otherwise the factoring won't work. So I'm going to add 13u to both sides, and you end up with that red equation right there. Now we can do AC method, which is just going to be 5 times -6, which is -30. And then we have to think of two numbers that add to 13, but multiply to -30, and that would be 15 and -2. 15 plus -2 is equal to 13. 15 times -2 is equal to 30. And that is perfect. So we're going to rewrite that red equation now by splitting that b term. So I'm going to do 15u plus -2u minus 6 is equal to 0. I'm going to factor the first two and the second two here. And you're going to end up with factoring out a 5u, and it's u plus 3. You're going to factor out a -2 here. It's also u plus 3. Again, it should match. If it's negative, definitely factor out that negative. And you're going to be left with the factored form to be u plus 3 times the quantity 5u minus 2 is equal to 0. Set each of those factors equal to 0, and you should be left with u is equal to -3 and 2/5 for the answers for that one. Okay, we got one more example for factoring here. I kind of do this off to the side so I have room. First thing I'm going to do is rewrite it so it's in standard form by adding 3 to both sides, and you end up with something like this. Your AC is going to be 4 times 3, which is 12, and your B is 7. And this one's kind of easy because it's just 4 plus 3 is equal to 7. 4 times 3 is equal to 12. And then what we're going to do is rewrite this by splitting that B term. So 4w plus 3w plus 3 is equal to 0. If you notice, this matches the red equation right here. It's just the B term is split, and that allows us to do some factoring by grouping, and you end up with 4w, w plus 1 w plus 1, there we go, plus 3 times w plus 1 equals 0. Factor out the w plus 1, and you end up with the quantity w plus 1 times the quantity 4w plus 3 is equal to 0. And your final answer is going to be w is equal to -1 or -3/4. All right, next thing we're going to do is using square roots to solve quadratic equations. And namely, if you have something squared, like this example right here, it says x squared equals a. What you can do is just take the square root of both sides, and once you do that, you can solve. Okay, it's essentially what it says right here. If x squared equals a, then x is equal to the square root of a and the negative square root of a. Okay, it's the plus or minus version of each of those. All right, so this one right here, it says solve for x using square roots. So what I'm going to do is subtract 3 from both sides first. So this is going to cancel, and you're left with x squared is equal x squared. You're going to get x squared is equal to 9. From here, I'm going to square root both sides. And once you get that, once you do that square root, you should have x is equal to plus or minus 3. And the reason why it's plus or minus is because of that red equation. If you look at the red equation, I'm actually going to parse that out really quick and just write it over here. So x squared is equal to 9. Well, if x was equal to -3, it'd be -3 squared, which is equal to -3 times -3, which is equal to 9. So we know 3 times 3 is 9, but also -3 times -3 is also 9. So anytime you do a square root, you have to do that plus or minus. Anytime you see that square root, make sure you do the plus or minus for your answer. Okay, let's do the next one. Solve for w. Okay, so we have that squared already on the left side. So what I'm going to do is take the square root of both sides right away. Okay, and you're going to be left with w minus 6 is equal to plus or minus 7. If you remember the rule, anytime you do a square root, you have to have that plus or minus. So I have the plus or minus 7. Then I'm going to add 6 to both sides. So you're going to be left with plus or minus 7 plus 6. And when you do that, that's equivalent to 7 plus 6 and -7 plus 6, because it's plus or minus 7. So you're going to end up with 13 as your answer and -1 as your answer for that one. You have to solve them both. All right, the next one says solve by using square roots. You really don't need a square root on this one, but it says to do it, so I'm going to do it anyway. And it's going to cancel out this squared here, and you're going to be left with 2x plus 3 equals plus or minus 0. But there is no such thing as plus or minus 0 because 0 is neither positive nor negative, so I'm just going to keep it as 0. If you solve this equation, you're going to be left with x is equal to -3/2, and that ends up being the answer because there's no plus or minus. So this one does have one answer. If it ever has a 0 like that, you're going to end up with just one answer. It won't be the plus or minus. This does kind of introduce the idea of multiplicity, but we'll talk about that a different day. All right, next we're going to be talking about completing the squares. There is a process for completing the squares, and that's essentially what I'm going to go through. I'm not going to really worry about reading through all of this right now. I'm actually just going to go shoot right to the example and try to kind of teach this concept by using an example. I feel like that's the best way to do it. So first thing that we're going to do is just complete the square. So basically we need to make this, at least part of it, have a perfect square in it. So it's going to be something squared. So what I'm going to do for this is I need to add a specific number here that's going to allow this to be a perfect square. And the easiest shortcut way of doing this is if you divide this b term right here by 2 and square it. So we're going to do 2 divided by 2, and then we're going to square it, and you get 1. So I'm going to put a 1 there. The issue with this is you can't just add a 1 in an expression because now it's not equal to x squared plus 2x anymore. I changed the value. So in order to kind of even it out, I'm going to also have it subtracted by 1 here. So now everything is still the same. It's just got a fancy +1 and -1 right after it. From here, what I'm going to do is I'm going to factor this part right here. Okay, and I'm going to use that AC method that we were talking about before. So AC is going to be equal to 1. Your B is equal to 2. So you have to think of two numbers that add to 2 and multiply to 1. And those two numbers would just be 1 and 1. So it's 1 plus 1. We're going to split that middle term. So you're going to have x squared plus x plus 1 minus, well, yeah, I'll just do the minus 1 over here. But we're only factoring this part right here. Okay, we're going to factor by grouping here and here, here and here. And you're going to be left with x times x plus 1 plus 1x plus 1, because there's nothing that factors in that second group there. There's still a minus 1 over here. Then you're going to be left with, when you factor again, x plus 1 quantity squared minus 1. And then you completed the square, because now, if you notice, there is a perfect square in there because it's x plus 1 quantity squared minus 1. So that's essentially how you do the completing of the square. You have to take that b term, divide it by 2 and square it, and then you have that number right there, that plus 1. You have to have that negative 1 to kind of balance it out there. Otherwise, the expression is no longer equal to what it started with. Then from there, I factored that first part. If you notice, I highlighted in yellow there, this top part right here. I factored like we were doing in the other problem, and then basically you're just working that all the way out until you have that perfect square. Okay, it is important to note that if you divide this b by 2 and square it, you will always get a perfect square in that parentheses. Okay, hopefully by doing a couple more examples, this will make more sense. Okay, here we go. This one, it says solve by completing the square. So first thing that we're going to do is, this one's an equation this time. So what I'm going to do is I am actually going to move the 3 to the other side. So I'm going to subtract 3 from both sides. Then I'm going to do the same thing I did in that other problem where I divided the b by 2 and squared it. So 4 divided by 2 is 2, squared it's 4. Now since I added 4 on the left side, I have to equally add 4 to the right side. Okay, this keeps everything balanced. It's similar to that plus 1 minus 1 that we did in the problem just before this one. Okay, if you factor this left side equation, you should get x plus 2 quantity squared. Okay, so if you want to do the AC method and work that all out, you'll get quantity x plus 2 squared is equal to 1. And then it says we have to solve it. So what we're going to do is square root both sides. And you're going to be left with x plus 2 is equal to plus or minus 1. You're going to subtract 2 on both sides. So you're going to get plus or minus 1 minus 2, which is equal to 1 minus 2, which is negative 1. And negative 1 minus 2, which is negative 3. And that's the two answers for this. And I basically just solved this using completing the square. All right, let's do the next one here. Okay, this one is not set equal to 0. It's also not even set up in the form to use completing the square. So what I'm going to do here is I'm going to switch the 13 and the 6x. So I'm going to subtract 6x on both sides, and I'm going to subtract 13 on both sides. From here, I'm going to divide this by 2 and square it. So it's negative 3 squared, that's positive 9. And if you add 9 on one side, you equally have to add 9 to the other to keep everything balanced. The equal sign means you have to keep everything equal on both sides. What you do to one side, you equally have to do to the other. This is going to factor out to x minus 3 quantity squared. Okay, if you want to do the AC method and work that all out, you can. I'm just going to try to save time in this video. This is going to be equal to negative 4. We have to square root both sides. And hopefully, a light bulb's going off in your head. Oh my gosh, I have to do the square root of a negative. That's going to be an imaginary number. And it is. So what we're going to do, this is really plus or minus 2i. Because this is actually equal to I times the square root of 4. Well, plus or minus I root 4. And that root 4 is equal to 2. So it's plus or minus 2i. And then what we're going to do is we're going to add 3 to both sides. So your final answer is 3 plus or minus 2i for this one. So this one actually has an imaginary number because you're doing the square root of a negative. Okay, namely the square root of negative 4 right here causes an imaginary number to come out. So you have a complex solution to this one. If you're confused on the imaginary numbers, the complex numbers there, then you're going to want to watch the previous video because we go over all of that there. Okay, there is a third way of solving quadratic equations called the quadratic formula. And it says by completing the square, you can derive a formula that is capable of giving the solutions to any quadratic equation. I'm not going to really waste time on that. There is a video that I already made that kind of goes over where this equation comes from, this quadratic formula, where this equation comes from. So if you are interested in that, definitely check it out. It's going to be a little bit weedsy. It's stuff that we don't really necessarily need to know for the class. The main thing is actually being able to use that formula to solve quadratic equations. So, but again, if you do want to check that out, could be worth it if you're interested. But anyway, we're going to use that quadratic formula to solve some quadratic equations. Also, this section introduces the idea of what's called a discriminant. Basically, it's this part right here in the square root, that b squared minus 4ac. If it's equal to 0, you're going to have one solution. If it's greater than 0, you're going to have two real solutions. If it's less than 0, you're going to be doing the square root of a negative, so you're going to have two different complex solutions. I'm actually going to show you how to do all those examples as we go here, but just know if it says like find the discriminant, it means find b squared minus 4ac. It'll make sense as we go here. All right, so let's start with 13 here. Okay, so quadratic formula, you need to know what a, b, and c are. So in this case, a is equal to 3, b is equal to -8, and c is equal to 1. So from here, we know that x, since it's equal to 0, x is going to be equal to -b, so -8, plus or minus the square root of b squared, which is 64, minus 4 times 3 times 1, because it's 4ac. This is all square root here. This is all divided by 2a, which is 2 times 3, which is 6. Okay, you should know where all of those numbers come from. I was basically just using the quadratic formula that's written up here. Right here. Okay, so it's -b plus or minus the square root of b squared minus 4ac. That orange step right there, you should be able to see where all those numbers came from. If not, definitely make sure you ask. Okay, the next step is to simplify all of this. So this is going to become positive, so it's +8 plus or minus. This is 64 minus 12, which is going to be 52, so square root of 52 here. So this is going to have two real solutions here because the discriminant is greater than 0. And then we're dividing by 6 here. Okay, the square root of 52 actually does break down to the square root of 4 and the square root of 13. So there is a perfect square in there with that 4. And the square root of 4 becomes a 2. And the last step is simplifying everything. If you notice the top and the bottom, everything has a factor of 2 in it because the 8 has a 2 in it, the 2 root 13 has a 2 in it, and then the 6 on the bottom has a 2 in it. So what I'm going to do is divide everything by 2. So you're going to get 4 plus or minus root 13 over 3, and that is your final answer. All right, the next one, it says solve for x, round your answer to the nearest hundredth. Okay, so we're going to set this up in quadratic formula, and then I'm going to use my calculator to get the decimal approximation of that to the nearest hundredth. So that's 2 decimal places. So first thing we're going to do is we're going to set up the equation. So a is equal to 4, b is equal to 1, c is equal to -4. Okay, using quadratic formula, it's going to be x is equal to -b, so -1, plus or minus the square root of b squared, which is 1, minus 4ac, which is 4 times 4 times -4. And then this is all divided by 2a, which is just going to be 8. Okay, this minus and minus become a plus, and then you end up with -1 plus or minus the square root of 1 plus 4 times 4 times 4, which is 64, plus 1 is 65. So I'm going to put a 65 in here, and this is all divided by 8. And it says round your answer to the nearest hundredth. So again, 2 decimal places. So what I'm going to do is throw this in my calculator. I'm going to do the plus version and the minus version. I'll do the plus version first. And you get 0.88 with the plus version. Okay, if you do the minus version, you get negative 1.13 as the answer. So those are the two answers for that problem. Okay, onward we go. It says solve for x here. And then we end up having a is equal to 3, b is also equal to 3, and c is equal to 7. Okay, using quadratic formula, we're going to have x is equal to negative b, so negative 3 plus or minus the square root of b squared, which is 9, minus 4 times 3 times 7. Okay, so we're going to have a negative number in the square root here, so this answer is definitely going to have a complex solution. We're divided by 2a, so that's going to be a 6 there. Okay, let's simplify this out. You end up with negative 3 plus or minus 9 minus 12 times 7 is negative 75. So the square root of negative 75 here divided by 6. Okay, so that negative 75 can actually break down. So we can pull the I out of there. We can also pull a 25 because that's a perfect square. So negative 3 plus or minus, I'm going to take the I out of there, and it's going to be root 3 times root 25. All of this is divided by 6. The root 25 is just 5. So you end up with negative 3 plus or minus 5i times root 3, all divided by 6. So not the prettiest answer in the world, but it is the answer nonetheless. Okay. The next one, it says use the discriminant to determine the nature of the solutions. Okay, so what we're going to do is we're going to figure out the discriminant, which is b squared minus 4ac. So we're going to figure that out for this problem right here. It's basically going to be 7 squared is 49 minus 4 times negative 4 times negative 1. So these become positive here. And clearly you're going to see that this is greater than 0, which means the discriminant is greater than 0. So you're going to have two real solutions for this problem. It says explain the nature for it. Well, the nature is that there's two real solutions. And the reason for that is because it's greater than 0. If it was negative, it would be two complex solutions. If it was equal to 0, it'd be one real solution. And the last thing, it says a ball is thrown from a height of 67 meters. Okay, so I'm going to draw this out first, just to kind of get an idea of what we're working with here. So, a ball is thrown, so it's thrown here. And this is 67 meters. Okay, initial downward velocity, so it's going downward 5 meters per second. The height of the ball in meters after t seconds is the following. Okay, so we didn't really need to write all that down because it actually gives us an equation that models this whole thing. So rather than a picture model, we can just look at this equation model. And it says, when does the ball hit the ground? So the ball hits the ground when the height is 0. So what we can do is just using this model, set the height equal to 0 and solve that. So what we're going to do is we're going to use quadratic formula on this. So it's going to be t is equal to negative b, which is 5, plus or minus the square root of b squared, which is 25, minus 4ac, so times negative 4.9 times 67. It is important to note that that equation is backwards with standard form. So it makes it a little trickier. But the a is still this right here. This is the b, this is the c. And then divided by 2a, so divided by negative 9.8. Okay, something like that. And then I'm going to throw this in my calculator because it says round to the nearest hundredth. There's no sense in trying to simplify all this because it's going to be an absolute nightmare. All right, so it's going to be 5. I'm going to do the plus version first. Okay, the plus version, if you round to 2 decimal places, is negative 4.24, which obviously doesn't make sense as a time because you can't have negative time, so we're not going to look at that one. And then the other one, if you do the minus version, hopefully this one's positive. It is, and you get 3.22, and that is the answer for this one. Okay, when it hits the ground is, when the height is 0, so that's why I set it equal to 0. Once it's set equal to 0, you can see that you can use quadratic formula. So that's a quick overview of solving quadratic equations. If you have any questions about anything in this video, let me know.